It's hard to believe that something as beautiful as this could potentially be lethal. But lurking behind the iconic central lantern was one of City Hall's biggest safety concerns.
We're standing above a plaster ceiling, which is made of fibrous plaster on timber battens, so it's quite weak. We have this walkway that we're standing on, which is actually floating above it, and as you can see, it's predominantly made of timber, so it's quite flexible, and it's very, very old. One of the dangers that's present here for people who use this space to alter the lighting for the auditorium is the danger of them falling through this and actually falling through the plaster ceiling and landing onto the floor below.
It was not until the restoration commenced that engineers realised that the shape of the dome ceiling cavity would capture excess water set off from fire sprinklers inside the dome. The timber framework supporting this magnificent lantern is not strong enough to carry the weight of the water, and in the case of a fire, the likely scenario is that the entire ceiling would come crashing down. This is just one of the examples where, unknowingly at the time, new technologies introduced to the building have had a detrimental impact on the building's structure and safety. As work began to erect a brand new ceiling, we went back up inside the dome to see how the new ceiling will simultaneously fix the structural strength, fire safety issues and those annoying acoustics problems. Well, this has got to be a one and only view of the dome, hasn't it?
Well, they tell me that no one's been able to see this since 1925, really, but perhaps when a bit of maintenance was done along the way, there were opportunities to see this going on. But you can see this material here, which is called vermiculite. It was put up in 1976 to deal with the acoustic issues. It sort of did help, but what it did, though, in combination with the sprinklers that are above us, then created this fire safety ceiling collapsing problem as well, which we'll now address. We are going to build on what was done years ago. This timber goes, but the steel that's above us will be used to suspend the new acoustic ceiling of the dome. So we'll have modern technology but supported by the original work, and that should deal with the acoustic issues in City Hall.
Just a few short months later, and I got to go up a second time to witness the dramatic changes happening inside the dome, and to get a very unique view of the lantern, a view only ever seen by the few who've serviced the dome over the years. And staring 23 metres down to the ground, a view not for the faint-hearted.
Well, Lord Mayor, last time we were up here in March, we were talking about the removal of the old wooden frames, the old ceiling. It's looking very different now.
Look, it's changed a lot, hasn't it, Andrew? A lot of that sort of garbage, I think, has been removed, really, and it looks very clean and robust now. It's great to see, particularly this issue about the runoff of the sprinkler system, the fire sprinkler system. Water now is being dealt with these great new box gutters and the material we're standing on.
Now, these walkways obviously look very different now as well. Why do we need this kind of access up here in the dome?
Well, there's an ongoing need for access up here for maintenance purposes, for the adjustment of lighting, when light globes, for example, blow, etc., work on the wiring. You always need to get people up in here, and so you have to have proper, safe walkways and effective, safe access.
So, the engineers tell me this ceiling couldn't be safer. But what about those acoustic problems? Since City Hall opened in 1930, poor acoustics have been a constant source of complaint in the main auditorium. Over the years, various measures were taken to improve the acoustics, but nothing really worked.
Not only was the acoustic not adequate, it wasn't flexible enough. It really wasn't sufficient to give the quality of sound that the room deserved, and it certainly didn't give it the flexibility that it needed to be able to have an organ concert one day and then the Queensland Symphony Orchestra the next day. So they're the sort of parameters that generated the design of the new ceiling and the new acoustic solution in the space.
Thanks to the very latest technology, engineers say they found an acoustic solution that will fix the problem once and for all.
Well, one of the big challenges with the hall is the shape of the hall. Being a big circular, hall with a dome roof. Circular shapes aren't a great thing acoustically. They tend to focus the sound, so you end up with dead spots and really loud spots in the hall. It wasn't ideal, so we're sort of working against the geometry from the start. You're also trying to develop a solution that respects the heritage of the hall whilst also struggling with the fire and the structural and all the other design constraints. So it was quite a challenging project, but an interesting one.
And what have you been able to do design-wise to change that?
Well, one of the key elements of the design is replacing the dome ceiling with an acoustically transparent ceiling. It's a new product called Barasol, which is a stretched fabric that means we can keep the shape of the dome visually but remove it as an influence on the hall acoustically. It means we can put some of the other treatment behind the ceiling where it's not as obvious. We've also incorporated some variable acoustics, which means that it'll change a bit depending on the mode, but in something like an organ recital, the reverberation times can be a lot longer, so you get a lot richer sound and a lot warmer sound from the organ, and then in things like banquets it'll be shorter, so you have less interference with speech.
So, now that the problems in the dome ceiling have been resolved, it's time to move on to some of the other parts of the building. And if you thought the threat of the auditorium ceiling collapsing was a scary thought, wait till you see the results from some of the other investigations coming up next.